Hi everyone, and thank you for watching. In this question we have a graph and you have to find the intervals in which the function increasing, decreasing, concave up, concave down, and you have to find the x values for the critical points and inflection points for the curve. In the first part of the question we have 7 questions. This is the first one. Find the intervals in which f is increasing. It's easy to find that the function y equals of x increasing in this portion only. So we are talking about the interval from 4 to 6. So the interval of increasing from 4 to 6. Now in part B you have to find the intervals in which the function is decreasing. Decreasing, we have 2 intervals. This is the first one, and this interval from 1 to 4, and we have another decreasing function which is from 6 to 7. So these are the intervals in which the function is decreasing. In part C you have to find where is the function f concave up. Now you can see this portion is concave up, this portion is concave up also. So we have 2 intervals. The first interval is from 1 to 2 and the second one from 3 to 5. So these are the intervals of the function at which the function is concave up. Now in part D you have to find where is the function f is concave down. This is part D, and the function is concave down in these intervals. The first interval from 2 to 3, 2 to 3, and the second interval from 5 to 7. Now in part E, find all values of x at which the function f has a critical point. Critical points means f prime of x equal to 0 or f prime of x does not exist, and x must be in the domain of the function. As you see, the function is continuous and differentiable on its interval, but always the end points of the interval is a critical point. Here we have 2 endpoints. The first one is 1 and the second one is 7. And at these 2 endpoints, the function or the derivative function does not exist. F prime of x does not exist. So to find the x values of the critical points of the given function in part E, we can say that x equals to, first you have to take the endpoints 1 and 7. Then you have to find where is f prime equal to 0. Here we have maximum point, and here we have minimum point. So here f prime equals 0, and here also f prime equal 0. And this happens when x equal 4 and x equal 6. So these are the x values of the critical points for the function f. Now in part F you have to find all values of x at which f has an inflection point. Inflection point means the point that the function change its concavity. Okay, and this is easy to see from the graph. Here we have concave up and here we have concave down, and this happens around x equals 2. So the first x value for the inflection point is x equals 2 because the function f changed the concavity around x equals 2. The second x value for the inflection point is x equal 3 because here the function is concave down and here the function is concave up. So we have also x equals to 3, and also we have x equal 5 because we have change of concavity. Here we have concave up and here we have concave down around x equal 5. So the second x value of the inflection point is x equals 5. So these are all x values of the inflection points of the given function. Now we'll go to the next part. Part B. Use the graph to make a table that shows the sign of f prime and f double prime over the intervals from 1 to 2, from 2 to 3, from 3 to 4, 4 to 5, 5 to 6, and 6 to 7. So here the first interval from 1 to 2. From 1 to 2, this is the first interval. As you see, the function is decreasing, and when the function is decreasing, this means f prime is less than 0, which means it is negative. So in this interval, f prime is negative, or simply we can write negative sign. Now in this portion, or in this interval from 1 to 2, the function is concave up, and when the function is concave up, the second derivative will be positive. So the sign of f double prime is positive in this interval. Now in the second interval from 2 to 3, from 2 to 3, this is the portion. As you see, the function is also decreasing, which means the sign of f prime is negative, and the function is concave down in this interval. Concave down means the sign of f double prime is negative also. Now in the third interval from 3 to 4, from 3 to 4, as you see, the function is decreasing, which means the sign of f prime is negative, and the function is concave up in this interval. Concave up means f double prime is positive. In the next interval from 4 to 5, you can see this is from 4 to 5. The function is increasing, which means that f prime is positive, greater than 0. So from 4 to 5, f prime is positive, and the function in this interval is concave up, which means f double prime is positive also. For the interval from 5 to 6, as you see, the function is increasing, which means f prime is positive, and the function is concave down, and this gives a negative sign for f double prime. And for the last interval from 6 to 7, you can see that the function is decreasing, so f prime is negative, and the function is concave down, which means f double prime also is negative. So this is the idea of our example. You have to know that if the function f is increasing, f prime is positive, decreasing, f prime is negative, concave up, f double prime is positive, and concave down means f double prime is negative. And this is the end of this example, and that's it. Thank you.